Okay, here we go. I need to give you a little bit of an analogy on this. An arithmetic sequence is to linear functions, or to a linear function, as a geometric sequence is to another family of functions. It is exponential. Exponential is a function family that we have just finished discussing last chapter. We dealt a lot with exponential functions. This also means that when I give you sequences with whole number r values, I can't give you too many terms because they grow very quickly. We saw bases of 2, bases of e, bases of 3s and 4s, but not bases of 50s, because that just would have been difficult to work with. Here's an example of a geometric sequence. 5, 10/3, 20/9, 40/27. Can you continue it?
Maybe.
What's the next one?
81.
So what is the r value for this particular geometric sequence?
2/3.
Yeah, 2/3. You'd be multiplying by 2/3. But let us remember that to get the r value, you can always take the second term and divide it by the first, or the third term and divide it by the second, or we're going to keep a little ... going there, the nth term divided by the n-1th term. And so if you're struggling to figure out what the r value is from a forward-thinking perspective, let's go reverse and do 10/3 divided by 5, which is 10/3 times a fifth, which is 2/3. You can always figure it out by doing that math. I'm going to put a little break line here, and we're going to derive the formula for a geometric sequence. It is very much related to the formula for an arithmetic sequence with a few changes. I'm going to give you a basic geometric sequence. We're going to use this as an example to derive this. This is the most basic one you can do because this is the sequence 1, 2, 4, 8, 16, 32. And the positions of these are 1, 2, 3, 4, 5, 6. Position, value, same as before. This is a geometric sequence defined by what r value? You have to train your brain now to think in terms of multiplying instead of adding. So t of 1 is 1. We're going to do the same thing we did before. T of 2 is equal to 1 times what? 2. T of 3 is equal to 1 times 2 times what? How many 2's?
2.
How many 2's would T of 4 be?
3.
How many 2's would T of n be?
2 to the
n minus 1. Always one fewer. And then where did the 1 come from right here? It was the first term. T of n is equal to T of 1 times, what is 2? It's the r value as well. This is pulling it out because this is the r value, r to the n minus 1. And this is the sequence formula for a geometric sequence. This is the second of 5 formulas you're going to have to memorize. And off to the right, I want to kind of summarize this. We have 2 sequence formulas that we're going to use, arithmetic and geometric. The sequence formula for arithmetic, T of n is equal to T of 1 plus n minus 1 times d. And the geometric one, T of n is equal to T of 1 times r to the n minus 1. You should notice the similarities. Operations get upgraded. Instead of adding n minus 1 d's, you're multiplying by n minus 1 r's. Same idea, just a different context. This also means that now the math on this one is going to be much, much more oriented about trying to use some of the stuff we've done before with exponential functions. So let's do some examples. We're going to do lots of these. First one, I'm going to give you this one, -4, 12, -36, 108, and so on. This is an R value of -3. This type of sequence has a special name because of what it does. And I think you'll know what I mean when I say that this special category of a geometric sequence is called an alternating sequence. Can you tell me what this means when you have an alternating sequence whenever the R value is negative? Alternating is one that you deal a lot with in calculus. You have special theorems around alternating sequences. The goal for this right now is to find a formula. So a formula means that I actually want you to find t of n. I want you to find a formula for t of n. You won't find what t of n is. You're going to find a formula that inputs n and outputs t of n. And I want to show you all the different forms that your formula can take. Let's start with t of n equals, we need to know what t of 1 is, and that is -4. So t of n is equal to -4 times r to the n minus 1. Remember, the general formula is t of n is equal to t of 1 times r to the n minus 1. -3 n minus 1. I cannot multiply the -4 and the 3 together, because they do not have the same exponent. They don't. They're different. Much like we couldn't multiply things. If you multiplied them together, you would be saying the -4 is also raised to the n minus 1, and it's not. You will see answer keys that actually have this, but I would like to go one step further with you. I would like to simplify this. Here's how we're going to do it. We are going to use the properties of exponents we did in the last chapter to break up this part of it. And I'm going to break it up by using the property that when we multiply bases, we add their exponents. So I'm going to split this up. -3 to the n, -3 to the -1. I want you to convince yourself that those are the same thing. If I were to go backwards, I would be using the property that when we multiply the same base, we add the exponents. I'm just going a different direction now. The reason I'm doing that is because now my exponent is just n. And what is -3 to the -1? -1/3. And if I bring that together with the -4, I have -4 times -1/3. It's still like the -3 to the n. And what is -4 times -1/3? So an alternate form of this is 4/3 times -3 to the nth power. And that would also be a simplified form. I want you to know how to do both. I want you to know how to go from here to here and create a simplified version of this. Number 2, is a review problem. I told you this one was coming back. K minus 2, 3, and K plus 4. And what I want you to do is find K so the sequence is geometric. Find K so the sequence is geometric. What is the setup we have to do to force this to be a geometric sequence? It's going with hands here. Sid. How many of you have had geometry and remember the concept of the geometric mean? Does this not look a lot like that, where you set up a proportion in the same way, and you're making 3 be the geometric mean of K plus 4 and K minus 2? This is a very, very, very similar thing. This is actually where it comes from. But the best way to kind of treat it is that in a geometric sequence, T of 2 over T of 1 is equal to T of 3 over T of 2. Now this is a solve. And like before, I cannot guarantee that this will factor. That should be okay with you by this point. K squared plus 2 times k minus 8 is equal to 9. Or k squared plus 2 times k minus 17 is equal to 0. This clearly does not factor. So you have a choice of completing the square or quadratic formula. I'm going to complete the square because you said quadratic formula. K squared plus 2k plus 1, because that's half the middle term squared. We're going to move the 17 over to the right side and also add a 1. The left side factors into k plus 1 squared equals 18. Or k plus 1 is equal to plus or minus 3 square root of 2. K could be negative. And we get k is equal to negative 1 plus or minus 3 root 2. It should make sense to you that there would be 2 possible k values that would work. 2 possible k values. Because there are 2 possible geometric sequences. I want you guys to fill in the gap. 1, 9. I want you to put a number in there that will make that geometric. 3. Give me a second number.
3 1/4.
Negative 3. Plus or minus 3 will work. This is going to be a critical thing that comes up when you fill in the gaps. It means that there's more than one geometric mean that will work between multiple numbers. So let's keep that in mind, and let's move on to a systems problem. So we're going to up the difficulty again. And what I want you to do is I want you to find t of 7 for the sequence -2, 1, -1/2. There are 2 methods on this one as well. You can panic method it. If this was a problem on a standardized test, I'd probably panic method it because I'm already 3 terms in and it doesn't take that much time to multiply by 4 more 1/2 or 4 more -1/2. This is an R value of -1/2, is it not?
Yes, it is.
But let's just go ahead and do the mathematical way. T of n is equal to t of 1 times r to the n minus 1. This is the same math you're doing. T of 7 is equal to, what is t of 1? -2 times -1/2 raised to the 7 minus 1. Much like before, you guys are going to have to really know your powers of 2. So I get -2 times -1/2 to the 6th power, which is -2 times 1 over 2 to the 6th, 1 over 64, or -1/32. Remember, 2 to the 6th is 64. Commit that to memory. Remember, 2 to the 10th is 1024. Commit that to memory. Get your other powers of 2 based on those 2 values. You'll be fine. Let's go to number 4. We're going to up the difficulty again. We're going to find t of 8 if t of 2 is 24 and t of 5 is 3. You will not get full points or even close to full points if you guess and check. You will not get full points if you guess and check. This is not about getting an answer. It's about mastering a process. The process here is identical to what we did on the question, Maddie, that you asked, and the ones that we spent a lot of time on yesterday. I'm saying here's t of 2, here's t of 5, and I want t of 8. I'm thinking we need to create a system. So we're going to do the same system process we did before. I'm going to take this equation, and I'm going to plug ordered pairs in, this ordered pair into here, and then this one in. And I'm going to create 2 columns and kind of track this down. T of 2 is 24. That means that 24 is equal to t of 1 times r to the 2 minus 1. And if you simplify that, you get 24 is equal to t of 1 times r. Let's let that be for a minute. And let's plug the other one in. 3 equals t of 1 times r to the 5 minus 1, which simplifies to 3 is equal to t of 1 times r to the 4th. Yes, no?
How do we cancel things out?
It's a great question. We clearly can't add both sides because adding is not going to undo. One of the things that we could do is I could solve for one variable and plug into the other, but I want to give you a better way, a new way of solving a system that should make sense to you. It's identical to what we used to do when we put them on top of each other. In fact, I'm going to put them on top of each other again. I'm going to put 3 equals t sub 1 r to the 4th on top of 24 is equal to t sub 1 times r. I'm putting that one on top because the r to the 4th is bigger, so it's going to work out a little bit nicer. I used to subtract both sides, like make the second one negative and subtract, but I'm going to do something that's a little bit different. I'm going to divide.
Oh no. What was that? What was that also?
If I divide the left side, I get 1/8. Divide the right side, the t sub 1's cancel, and the r to the 4th over r becomes r to the 3rd, which means that r is equal to the cubed root of 1/8, 1/2.
Whoa, now we can solve the rest of it.
We're going to plug this in. I would plug, guys, please. I'd plug this in right there. We're going to get 24 is equal to t sub 1 times 1/2, or t sub 1 is equal to 2 times 24, 48. So now I have t sub 1, and now I have r. The question asks for t sub 8. So we're going to go back to t sub 8 is equal to t sub 1 times r to the 8 minus 1. And I'm going to substitute some values in. T sub 1 is 48. R is 1/2 raised to the 7th. Which means that we have 48 over 2 to the 7th. I'm not going to actually multiply that out because I'm just going to keep dividing by 2's. Cut the number of 2's down, so 48 becomes 24. I can take out 1, 2, 12, 6, 3. I can take out basically a 16, right? A 2 to the 4th. If you want to see the visual split up, let's make this 2 to the 4th times 2 to the 3rd. And what is 2 to the 4th? 16. We divide it, we get 3 over 2 cubed. We get 3/8. So that particular kind of system is going to take some practice. I get that. I know. Okay, I'm going to come back to this. Word problems from this are going to be arithmetic or geometric. And we'll say this. A person strikes a large nail in the ground. If she strikes 24 feet on the first hit, then she's incredible. We'll go inches because that's going to be taller than anything that ever was. In the first hit, and no, it's probably more like a spire going down in flames. Too soon? Oh. And 3/8 of the previous hit, each successive hit. For those watching this in the future, yesterday the Notre Dame went up in flames, so yeah, that was bad. Okay, if she strikes 24 inches on the first hit and 3/4 of the previous hit, each successive hit, how many hits needed to get 2 inches from the ground?
How tall is the nail? Is she on top of the nail?
Actually,
I mean, she's trying to get 2 inches from the ground.
that's
So
a very,
she has
very...
to be on top of the nail, throwing a hammer at the nail.
Wouldn't that hit her toes?
No, that's a very good question. We'll say that it starts 100 inches from the ground. So basically, what I'm actually trying to figure out is T sub n is equal to what? How far do I need to hit it? Starts 100 inches from the ground. I need to get it 2 inches from the ground. 98.
That's what I was like you're starting at 8 feet.
Yep. So we need to hit it 98, or get it to where it's 98 inches. So basically what I'm saying is 98 equals T sub 1 times r to the n minus 1. And let's start actually filling in some of this. 98 is equal to... Yeah, the first hit is going to be 24. You know what? Kill this question. I'm going to have to scratch this. This is a series question because every time we hit it, we're adding up the distance of the previous one. It's not a sequence, it's a series. We'd be adding the 24 plus the next one plus the next one. So,
That's 11/8.
no.
Yeah, so we
Just kill that. This is where I do some creative editing when I render this, and like Ben will just see a big gap and wonder where that was and what that came from. We're going to go with the real number 5. Okay.
I hate this. How about the next word problem has less words?
fewer words.
Fewer words.
Fine with the amount of words as long as we don't have to write them.
Let's do one like this. A culture of Giardia.
What's Giardia?
It's a single-celled eukaryote. A culture of Giardia doubles every 3 hours. If it contains 2 million now, how many will there be 2 days from now? This one can be a little tricky because of the doubling every 3 hours. Right now, T sub 1, there are 2 mil. We'll just say 2, and we'll let our units be in millions. In 1 day, what T are we at? How many 3-hour periods are there in a day? 8. Now, I'm going to argue we're not at T sub 8, though, because we're starting at T sub 1. We're at T of 9. The reason is because what's the difference between 9 and 1? 8. And does it make sense that there are 8 3-hour periods? Now, what would there be in 2 days? T sub 17. So I'm really asking T sub 17 is what? So we can do this now.
Why 17?
17 because it says 2 days. How many would there be 2 days from now? So if 1 day,
We're not adding point
1 day
words.
is 8 3-hour periods. So we add 8. Another day, 8 more.
Now, 9 plus 8, shouldn't it be 9? Shouldn't it be 17, say 25?
What?
A day, and then another day, and then third day. Oh, wait, no.
2 days.
Sorry.
2 days from now. So you just need 8 and 8 more. T sub 17 is equal to T sub 1 times R. So what is R here? Yeah. R is 2 because it says it doubles. Starting with 2 million, R is 2 raised to the 17 minus 1, which means that this is 2 times 2 to the 16th. Well, what is 2 times 2 to the 16th?
2 to the 17th.
2 to the 17th. And if you do 2 to the 17th, this is a super, super large number because this is how many million? We're going to say 2 to the 17th mil and let it be. It's too many to really get. Basically, that's too many.
Too many.
Okay, last one.
They need to die.
I did not. I said last section.
I'm running out of paper. And if I
Okay.
initially run out of paper, it's your fault.
You're building a staircase.
Am I?
From the first floor to the second floor of a building of something. The distance between floors is, we're going to make it wellness center size. We'll go 5.1 meters. We'll say that each step rises 300 centimeters. These are super large steps.
300. That's like.
We're
That's a meter. No, that's.
That's a third of a meter. Among. Yeah. You're doing this so you can actually jump up to the top of the wellness center.
Isn't there
It's like the
100
staircases
centimeters in a
design
meter?
that go up to the
That's
temple,
that's
and
3
they're, like,
meters.
almost
It is
vertical.
3 meters.
Yeah.
Oh,
These are stupid steps, Mr. Payne-Elliott.
Oh, 300 centimeters is 3 meters. Sorry, 30 centimeters will do. You're right.
There you go.
That's better.
I did that. That was me. I did.
I mean, it's still
I'm-
really large, but
How many steps are we going to do? So
Realistic stuff.
5.1 divided by 30.
I want to kind of get an idea here what step means, because your book has a problem like this and it actually messes it up. So if you have something like that, how many steps are there?
2 steps.
I would say there are 2 steps. Your book says there's 1,
What?
because it says not counting either floor themselves. It says that that's 1 step.
That makes sense.
Yeah, I can see
I
that.
don't think so, because you have
But
to
you're
step
still, your
twice
body
there.
is making a motion.
Just don't get overly concerned with your book's answer key on that. If you're within 1, you're probably fine, because your book subtracts 1 from an answer. So I'm going to say that we'll do T sub 1, which is the starting level. T sub 1 is what? It's going to be ground. Let's say that's the first step. So how far up this first step?
Oh, first step, 30 centimeters.
30.
We know that the common difference, we're going to add what to the next step?
30.
30. So T sub 1 is 30, difference is 30, and T sub n is how many?
5.1.
Make it centimeters.
510.
510. So this is just a question of saying, how do we get up to that? So we're going to use the formula.
No, because 5.1 is in meters. And meters are more than centimeters.
100 centi.
That's why they call it.
So let's substitute 510 is equal to T sub 1 plus n minus 1 times the common difference of 30. I would divide both sides by 30 right now, because it's going to be easier if you do that. 510 divided by 30 is 17, equals 1 plus n minus 1, which means n is 17. So we would say there would be 17 steps. And again, I'm defining steps as you're walking, you step up, that's 1, step up, that's 2, step up, that's 3, that's steps. Okay, now we're done.